Okay, now let's talk about one-to-one and inverse functions. First, let's talk about one-to-one functions. So a one-to-one function is a special function that maps every element of the range to exactly one element of the domain. So in other words, the outputs never repeat, or the y's don't repeat. Okay? So here, we're going to determine if the following is a one-to-one function. So all we have to do is look at our y's, see if any of them repeat. If they repeat, then it is not a one-to-one function. So we have a 6, 4, 2, 3, 6. Well, these two repeat, so it's not a one-to-one function. And this is how you write it, like shorthand. Math shorthand is 1-1. Okay. Now, if you'll remember the vertical line test, right, that was how you decided if it was a function. Now there's another one, it's called the horizontal line test, and this tells us if it's a one-to-one, okay? So if every horizontal line intersects the graph of a function in at most one point, then f is a one-to-one. So just like the vertical line, we're going to take and we're going to draw a horizontal line, and if it intersects the graph at more than one point, then we know it's out. So if we draw a line here, it intersects twice, so we know this is not one-to-one, right? But here we could pick any point on this graph, and if we draw a line across it, it intersects at only one point, right? So this one is one-to-one, okay? And we can do the same thing with these down here. Let's pick a different color since the graphs are blue. Draw a line only once. So this guy is one-to-one. This guy, no dice though, right? Because he's not one-to-one. What about this guy? Well, we intersect there 3 times, so definitely not. What about this one? Only once. Only once. So he is one-to-one. That's good. Here's a little theorem I found in the book. A function that is increasing on an interval I is a one-to-one function. So you can see this one is increasing, right? So he's one-to-one. A function that is decreasing on an interval I is one-to-one function. So if he were just to be strictly decreasing, he would be a one-to-one. So that's a really good tip. This one is increasing, right? So that's pretty cool. The theorem, I thought. So any function that passes the horizontal line test is one-to-one. Okay? So add your horizontal line test to your little toolbox, right, with your vertical line test. Okay. Now, not all functions have inverses. A function must be one-to-one to be invertible. So if it's not one-to-one, he will not have an inverse. Okay? It's very important. Okay, so recall that a relation is a set of ordered pairs, or can be a set of ordered pairs, right? A relation can be many things, but it is a set of ordered pairs. The inverse of a relation undoes that relation, right? So the inverse of a relation is the set of the same ordered pairs with the first and second coordinates exchanged. So you're just going to flip or switch. Switch x and y. Therefore, the domain of the relation is the range of its inverse, and the range of the relation is the domain of its inverse. Excuse me. Here's the definition of the inverse of a function. So we're going to let f and g be two functions, okay, such that f of g of x, composite, right, is going to equal x for every x in the domain of g. And g of f of x, again composite, is going to equal x for every x in the domain of f. So if f composed of g equals x and g composed of f equals x, then they're inverses. Okay? Inverses of each other. The function g is the inverse of the function f, and it can be denoted by f, and then f has this little -1 up here. That is not a power, that is red, f inverse, okay? Not f raised to the -1. That is f inverse. Thus, f of f inverse of x equals x, and f inverse of f of x equals x. The domain of f is equal to the range of f inverse and vice versa. Okay, let's look at this example. So we have f equals this set of ordered pairs, okay? So first we're going to find the domain of just f. So our domain is going to equal, wow, that was impressive. It's the ugliest one ever. Okay, our domain is going to equal -2, -3, -8, and 6, right? Just our x's. Now we're going to find f inverse. Now remember, when we find f inverse, all we do is we switch the x's and the y's. Okay, so switch these. It's going to be 6, -2. That's really just as hard as it is, okay? 5, -3. 9, -8. Sorry, I forgot to turn my sound off on my computer. So it means sometime I will remember that. So that's our f inverse, right? We just switch our x's and our y's. Now, let's find our domain of this. So it's going to be 6, 5, 9, and -9. Okay? Right on. Now let's verify these inverses. Remember, we have to do our composition, right? We have to do f composed to g and see if it equals x, and then g composed to f and see if it equals x. So first, I always start with f composed to g. That's just my favorite. So we're going to do f of g of x. It's not my favorite. This is what I start with. So we're going to take this g and plug it in for x. Okay? So we're going to have 3 times x minus 2 over 3 plus 2. So our 3's cancel. That's going to leave us with x minus 2 plus 2. Well, those are going to be 0, so that's going to equal x. Okay? Now let's do g composed to f. So now we're going to take our f and put it in place of this x. So we're going to have 3x plus 2 minus 2 all over 3. Well, as we've already stated, if you have a positive 2 and a negative 2, they just go to 0. So we're going to have 3x over 3. I don't know if I can change colors. We'll do something. There we go. Our 3's cancel. That equals x. So they both equal x. So we know that means that they're inverses of each other. Okay? Everybody cool with that one? Not too bad? Okay. Let's do this one. Okay. Again, f of g of x. Let's see what that equals. So we're going to take this and put in place of this x. So 3 x minus 8 over 3 plus 8. Our 3's cancel, leaving us x minus 8 plus 8. Kind of see a pattern here. Leaves us x, right? All right. Now, g of f of x. Sorry, messed up. Now we're going to take this and plug it into our x. So we're going to have 3x plus 8 minus 8 over 3. 0 again. 3x over 3. This is going to be x. So again, they're inverses. Alright. That's kind of what we really want them to be. Let's do this one. See what happens. Okay. So we're going to take f of g of x. So again, we're going to take this and put in place of the x. So we're going to have 7 x plus 7 over 8 minus 8. Well, we don't have our happy little cancellation, do we? So we need this to be written over 8. So if we write him over 8, that's going to be 64 over 8, right? 8 times 8 is 64. So we have, multiply this in, 7x plus 49 minus 64. And since he's written over 8, we could put the whole thing over 8, right? Common denominator. We love that rule. 64 minus 49. It's going to be 15. So this is going to be 7x minus 15 over 8. Okay? Definitely not x. Alright, let's do the other one. So now we're going to do g of f of x. So again, we're going to take him, put it here. So we're going to have 7x minus 8 plus 7 over 8. So it's going to equal 7x minus 1 over 8. Well, neither one equals x, so we know that these are not inverses. Okay? So I just wanted to throw one in here for you guys to see what it looks like when they're not inverses, as opposed to I had just all inverses in there earlier. Okay, now let's find the steps for let's do the steps for finding an inverse. Yeah, that's the words I wanted. Okay, so these are the steps for finding inverses of a function. It's the same 4 steps. So once you get these steps down, you've got it, right? The only way they can make it harder is the solving for y part right here, right? And you guys are good, so they're not going to throw you on that. I call this the switch and solve because we just switch places with the x and y, right? Just like we did in the ordered pair, we do the same thing with an equation or function, okay? So we're going to, first thing we do is we substitute y in place of f of x. Then we interchange, or I like to say, switch. Okay, that's where the switch and solve comes from. Then we solve for y. And after we solve for y and get our final answer, then instead of having y equals, we're going to switch back to f inverse of x because we are finding the inverses, so I need you to tell me that's what it is, okay? Alright, let's do some. I wish I didn't have that on another page so you can see it, but we're going to just kind of step it out anyway, so let's do it. So number 1, we're going to put y in place of f of x. Okay, that's my shorthand. I hope y'all dig it. So I'm lazy, you guys know that. I'm going to probably tell y'all that the whole class, but instead of rewriting the whole problem, I'm going to work smarter, not harder. I'm just going to mark out this f of x and I'm going to put a y over it, okay? There's no sense in rewriting that whole thing, and please don't do it don't make a big deal about doing all that stuff, just write it out, you know what I'm saying? Like when you write the homework down on your paper for me, for the submission, write f of x equals this, or just write y equals this if you want to. You know what I'm saying? Don't, come on, man. Alright, so step 2. Now we're going to switch x and y. Okay, now this is where a whole bunch of people try to get all tricky and make it fancy. Don't go there. It's super simple. There's a y written on this side, you're going to write an x. There's an x written here, you're going to write a y. That's it. It's not tricky, okay? Don't overthink it. That's all you're going to do. Now let's move on to 3. 3 says to solve, so that's what we're going to do. Up until now, we've kind of been solving just for x, so don't get twisted up in your head, okay? Like, we're really solving for y. If you got to write that, write it. We always move the man who stands alone, so that means add 5 to both sides of the equal sign. X plus 5 equals 7y. We're not done because we want y by himself, so we're going to divide by 7. Okay, what I see people do all the time is like, break this apart. Just leave it like that, yo. 7 equals x plus 5 over, or y equals x plus 5 over 7. That is your answer, right? Except for now we have to do step 4. And what color do I want that in? Dark blue. So 4. Now we're going to put our f inverse of x in place of our y. So it's going to be f inverse of x equals x plus 5 over 7. And you're done, okay? The only way you wouldn't be done is if we had a variable in the denominator and you had to tell me what the exclusion was. Alright? Okay. Let's do another one. I'm not going to rewrite everything because the steps are right there. Again, Should I lazy? Again, here we go. Y is right here. Purple. Switch x equals y cubed plus 1. Now we're going to solve. Oops. So we're going to subtract 1, right? Move the man who stands alone. X minus 1 equals y cubed. We got to get rid of this cubed. How do we get rid of a power? By taking the root, right? So this is the y to the third power, so it's going to be the cubed root. And then you would take the cubed root of this side. You don't have to use plus minus because it's not even. This cancels, so we're going to have y equals the cubed root of x minus 1. Final step, don't leave it y equals because y'all will count off points. So we're going to have f inverse of x equals the cubed root of x minus 1. Cool. Alright. Last one. Ooh, first one. Okay. So, switch this for y. And then now we're going to do x equals y plus 2 over y minus 3. Don't worry about this. This was just your exclusion when it was in its original form. Okay? Pay no attention to it. Now, let's get rid of this fraction. How do you get rid of a fraction? Multiply both sides by the denominator. These will cancel, right? Now, I'm going to pick a different color than we've used. We're going to distribute this x into both sides. So this is going to be xy minus 3x equals y plus 2. Okay. I have to go up here in a minute. Now, we want all the y's on one side, everything else on the other. Okay, so let's add 3x to both sides. So we're going to get xy equals y plus 3x plus 2. So I'm going to bring him up here. Okay, now, again, we need to move this y over here. So let's subtract y from both sides. Okay, but this one has an x in it, right? So that's not cool. We need that x over to the other side. So we can look and see what our greatest common factor is on this side. I'm going to switch colors again to something I haven't used before. Oh, red. Ooh, I don't like red, but there you go. So our greatest common factor between the two, they both have a y in common, so let's factor that y out. If I take y from xy, well, cover that y up and you're going to see you just have an x left, right? If I take x from negative x, that's not x. If I take y from negative y, I'm going to have a negative 1 left. And we did nothing to this side, so we can copy and paste. Now, I want just y over here. So I have to divide this number out. So I'm going to divide by x minus 1. Now if I lost some of you guys, I'm going to step over here and show you something. If I had 3y equaled 3x plus 2, and I wanted to get y by himself, how would I get rid of that 3? I would divide by 3 on both sides, right? This is the same thing. This could be 4 minus 1. For all we know, that is 3, right? It's a number. It's just a number. Don't get tricked up because it's a variable. Alright, so I'm going to go cancel these. So y equals 3x plus 2 over x minus 1. Okay? But we can't leave it y, right? We know that that's not kosher. The songs will count off if you do. So f inverse of x equals 3x plus 2 over x minus 1. But we have a variable. Messy. We have a variable in the denominator, so we have to find out what our exclusion is. So we set x minus 1 not equal to 0 and solve. We add this over. Find out that x cannot equal 1, right? So that is our exclusion on that one. So here is our answer. Our inverse, and there's our exclusion. Okay? This one's going to be super simple after doing that last one. Remember, make this be a y, then we switch. X equals 4 times y cubed minus 1. Oh, now I lose track of my colors. I don't know, we're just going to do something. Now, I think I should have changed colors there, shouldn't I? It's okay. Let's solve for the y. Add 1 to both sides. X plus 1 equals 4 y cubed. But we gotta get the y cubed by himself before we can remove the power, right? So let's divide by 4 on both sides. So it's going to leave us y cubed equals x plus 1 over 4. I like my y on the left hand side. If you don't want to do that switch, you don't have to, right? It's your submission work, like you do you. Now I have to take the cubed root of this, and this is going to be a big cubed root. This 3 and this. Oh, that's so wrong. This 3 and this cancel, so that's going to be y equals the cubed root of x plus 1 over 4. And then our last step, I know that's always blue, so this is going to be f inverse of x equals the cubed root of x plus 1 over 4.